Design, vision, management decisions, and code. Well, these are the things that are incredibly valuable to get on top of. And so let's have a look at these. So all developers should be more literate in the language of design. And yeah, this needs to be something actively looked at, right? You need to see whether the developers are capable of reaching and doing the kinds of designs that you need. Good code is even more important in agile environments. So often people put all the emphasis, the agility in a process, and that's the antithesis, right? So agile and process don't go. You need a good process, but that doesn't make it agile, right? What makes something agile is more and most likely the mindset and the code base to enable that mindset, right? Design decisions are being made by developers every hour, and yes, this goes along with the developers being more literate in the code, but it's important, right, to take note that they're making decisions, and those decisions, whether it's a test and then a design or a refactor, those decisions are changing the design all the time. Are design decisions being thought through carefully with experience? Right, so yeah, people make mistakes. You don't want to design everything up front, but how carefully are people looking at the problem, and are they spending enough time evaluating and coming up with something better? We all know that you could come up with a solution, 80% okay in a relatively short space of time, and you can do that. Most people are doing that, but to get to that final 20%, that polish, that robustness, that really, really good design, that efficiency, the qualities of the design on all the spectrums are good, that's going to take that 20%, that's going to take more thought and experience. And how does the team communicate design, right? The design vision. So if I understand that I need to build greater extensibility, and we all understand that, then we'll be on the same page. So let's look at AMMERSE. Now, AMMERSE is a heuristic mnemonic. There are 7 principles. And I designed these principles to not only be in of themselves a principle to take heed of, but also the 7 of them applied as weights, the 7 of them as separate categories of understanding. So within each category, I've placed design patterns, right, and many other things. So do not repeat yourself dry. Well, that exists within principle Agile, right? So those kinds of things categorized among the 7 categories, those 7 principles, means that you have a means of deciding which patterns to use or what kind of principles to apply. So heuristics and other principles all sit within these 7 principles. And if you think about it carefully, we've got methodologies for process and management and all of that. We've got design principles such as solid, but we don't really have the communication principles that link those 2 things together. And that's what I think AMMERSE is capable of doing. And AMMERSE fits into any process methodology or X-driven paradigm. AMMERSE elegantly aids you in prioritizing design constraints without interference. You don't really need an architect to interfere and do designs for you. You can say, these are the weights. I think that the 7 principles are weighted thusly. Therefore, your vision and people can follow that and make decisions as normal, but now they are guided within that vision. And that categorization, those principles aid you in making good decisions. So here are the 7 principles. So let's just go through these 7. There's the AMMERSE Design Maturity Index as well. I'm going to go through each one of these separately hereafter. I'm going to give you a quick thing so we understand what we're talking about, and then we'll go into greater depth. So reachable is, can you reach the goal? Is there a budget or a timeline? Can your design reach there, right? So don't over engineer, you need to reach something, but is that timeline something that is good for the design. Maybe we need to push it back by a week. Solving, does it actually solve the problem? But not just, the problem, but what about meta problems? Is the solution creating other problems? Are there problems that arise later on because of the solution we've done now? Can this solve today's problem, but can it solve tomorrow's problem? So solvable. Then there's minimal. So this is not quite fit for purpose. We'll get into that in greater detail, but it's very close. Minimalistic, right? So we don't want to over-engineer. We want to do some simple things. We want simplicity. We want elegance. We want something designed to be good. So it's not just about saying, here's a function, it's minimal, right? That's it, right? It's about what the minimal design feature should be to allow extension, modification, and various other things that you'll find in these other principles. Environmental, well, code should be according to a coding standard. You should design something in line with the platform. It doesn't work like that in that platform. Well, that would be a bad design, right? So, everything is stateless and you build something that's stateful. That would be not environmentally friendly. Maintainable, and you'll see I've missed the T there, maintainable, and this gives you an idea here that I wish I did it on purpose, but it was a mistake. This poster was printed and 100 copies was given out, and there it is with a spelling mistake, but it's done. I wish I had designed this a little bit better and critiqued it a little bit better, and did that a little bit better. Maintainable. So what makes code maintainable? It's not just, making things neat, right? Or naming things, coding standards, things like that. It's also, you've used an abstraction, you've got a resource, a developer in there that doesn't understand those abstractions, is not maintainable for them. They have to now learn. There's a learning curve. There's various angles to maintainable. Extensible. So extensible is a plug. You can see it's a pluggable interface. So it's something you would install. It's a plug-in. You do not modify the thing that exists, right? You don't want to do that. You extend it. Okay. Agile. Agile is code that you can modify and snap into, and it's designed, but it's kind of a design time kind of extensibility, where extensibility is a runtime extensibility. I'll drop that piece of code in. Oh, look at that, I've got a new plugin. Whereas Agile code, according to the principles here, would be code where I could go and create a class and put that class in the right place. Oh, I've now got extensibility, but it's something I had to do in design time. So in framework kind of language, this extensible is kind of like the black boxed approach, think of it like that, and Agile is the white box approach. So that's a quick understanding of those principles. By the way, I have other videos where I describe these in various ways, because these principles can come through from a project management perspective, from a code perspective, from a design perspective. There are videos explaining a whole lot more about each of these principles. Please have a look in the playlist. So design maturity index, that's the next thing I wanted to go through now. And that is to say that I've got level 1, 2, 3, 3.1 over there. And let me explain how this works. So level 1 is the most rudimentary, this thing you need to do to solve a problem. Right? So the problem is, here's a set of requirements. Can you please do it for me? This is my budget. Okay, sure. Let me go ahead and do that. So what do you want to do? You want to reach the goal. You want to solve the problems in a reachable time frame. Right? So that's level 1. That's what we're all striving for. It's just to write some code that matches and reaches. And this is kind of like red-green refractor. The red, there it is. There's my test. It's failing. Now what am I going to do? Well, I'm going to write the specification immediately, and I'm just going to get that done, right? So now, oh, there it is, it's done. So that's level 1, because now you have something, it works, right? You can ship it, right, if you need it to. It's actually there, but it comes with, it's got technical debt in many ways, perhaps, right? Maybe it has no technical debt, but it might have design debt. It might be a terrible design or put in the wrong places. It might not be maintainable and all these other things. So getting that better, you have to move to level 2. And this is where I like to be as my default, right? These 5 together. My default in anything that I do is encompasses those 5 things. So I want minimal, environmental, and maintainable code. So I'll go ahead and take that reachable, solvable code, and I'll say, right, how maintainable is this? How environmentally friendly is this, right? So it's sitting in a code base. The code base has all these other patterns and designs. Well, mine is just sitting in a function. It's got, you know, sort of terrible coupling. It's this. And so now I want to pull it apart. And so I look at the following 3 things. How do I turn that into a minimal design? Right? So a design is actively choosing some things. It's not just minimal. There's a function, as I explained. It is a set of functions that work in unison in a certain way. It's a strategy. It's some kind of abstract class that does something, and there's a reason behind it. So minimal design, environmental design, and making that maintainable, together with reaching and solving, that is my go-to level 2. And I really don't think anyone should go for level 1 in this day and age, but I mean there are people who purely, right, and I'm thinking outsourcing perhaps, right, we've got a specification, we want to solve the problem, just reach the goal, solve the problem in a budget, that's it, right? If we've gone over a bit, we can't charge more, but we'll just get it done. We'll throw some more resources at it, for example. Right, so level 2 is a minimum. Now, level 3 is something that you could strive for immediately. You know, if you're a startup and you're saying, well, the whole central operating mechanism, the whole core value of our startup is to have layers of abstractions and implementation, adaptability, and so on. Well, then you want to do Extensible and Agile. You want to go to level 3.1 or level 3 straight away. And the difference between those is level 3 is when you make your code extensible in a design time sort of way, in the white box sort of way. So let's say you have an abstract factory, you have a class, you have some specializations with high cohesion in a set of folders, and now you're going to use that. And you know, well, should you need X and Y, you can easily spin that code base up, go in and create and implement that class, implement that interface, snap it in there, register it, and you've got a new thing to add on. And that's a very good thing to do. You design, you need documentation, you've got some limitations, you have to, there's a learning curve, everybody has to know that that's, you know, how it works and so on. So therefore level 3 is good. It makes your code base malleable, but you still have some deficit. Extensible is when the base class, the design, the abstract factory, the specialization is locked down. It's done. It's as good as it's going to be. You don't need to extend it, right? So yeah, you don't have to modify it. You can extend it tremendously easy, and you can spin up a new IDE, implement an interface from, you know, something that's compiled. You do not have to go into that code. You're utilizing the output, the binary, the compiled assembly, the DLL. That's what you're using. You're using the framework, and that is a very good place to be, because it means that your platform has the stability, and you've been pushing your value down, and therefore or your capabilities have been pushed down and solidified and so on, and you can still extend on the top. And this is level 1, 2, and 3, and you can see why 3.1 is a logical next step for level 3. That's why I've named it 3.1. Just a psychological hint that it's just another 0.1 value to go and hit, right? It's often designed and processed, and you know, the agility is already there, everything is already there. Extensible, though, is maybe a business decision, right? It's to allow others to make extensible things. It's to allow another team to make extensible things. Maybe there's a marketplace for extensibility and so on. So it falls in line with another channel, perhaps within your business. So let's look at design maturity, how you move through these. Right, and as I said, you can opt to go directly to 3.1 in a particular feature. It doesn't have to be the whole application. And before I get into this, just a quick note now that I've just popped into my head. if you looked at your code base, at various parts of your code base, and start labeling them according to these principles and say, well, that's level 1, that's level 3, that's level 2, that's level 1, you can get a very good sense of your code base, right? You can get a very good sense of what you need to increase, where you need to increase technical capability and so on. Okay, let's look at this. So solvable, or solving, reachable over here, this is level 1, and you can see that you want to get your technical ability up slightly. Technical ability is all the artifacts and the technical things you have to do, create a class, get that in place. Maybe it's a website and it's a model view controller design pattern that in your architecture or something, and so you have to implement that and get your controller and your view separate. And we're talking technically now, not the MVC paradigm, but more how people have envisaged it in code. Get your technical, and then your business capability goes straight up, right? So you can see it's a big jump, because your technical capability is going to be quite rough and ready. You're just going to create some functions, create some classes. You don't really care, just put them all in place. It does the job, doesn't it? Right? Okay, so your business capability needs the next step and the next step and a new feature and a new thing and a new thing. And before you know it, it's quite wobbly, right? Because you're not really got a firm foundation. But you can reach it, and you can reach that goal, and it's solvable. And your next phase you want to go through is look at your minimal, maintainable, environmental. You want to get to level 2. So what do you do here is you really want to bump up your technical capability. You want to reach up to where business was, and your business capability will automatically increase a bit. You can add some more features, but you really want to concentrate on getting that technical side up to